This is part 3 in the series, Proving the Earth is Not Flat. The goal of this series is to show you how you can prove to yourself, with your own observations and experiments, that the Earth is a sphere. Today we will look at the Moon. It is important to understand a number of facts about the Moon so that I can show you how our observations of it can demonstrate that the Earth is a sphere, and how it can only work within the heliocentric globe model and not in any flat Earth model. The Moon is a sphere that orbits the Earth about once every 27 days. Some flat earthers will claim that the Moon is a flat disk, or just a light in the sky, or some sort of projection, or even a hologram. All of these are absurd and easily refuted by the evidence. The fact that there are many different explanations, and again I use the term loosely, for the Moon within the flat Earth community should tell you something. There is only one explanation in the heliocentric model, the right one. But how do we know the Moon is a solid sphere? Because no matter where you are on the Earth, when you look at the full Moon, it is always circular. Only a sphere looks round from all vantage points. If it were a flat disk, a light, or projection circling above the flat Earth, just a few thousand miles up, it would appear to look elliptical as it moves away from us, like this, because our viewing angle would change. Also, as I pointed out in part 1, it would shrink and disappear as it moved away, like this, if it were only due to perspective, as flat earthers claim. It never does this. It slides behind the horizon at the same shape and size as it was when it was overhead. Also, when you look closely at the Moon with magnification, you can see that the circular craters appear increasingly elliptical as they approach the edges, and exactly in the right direction, due to the curvature of the Moon's spherical surface. The Moon's phases are caused by the light of the Sun reflecting off the Moon. As the Moon revolves around the Earth, we see it at different angles in relation to the Sun's light. The moonlight takes on a series of shapes as it goes through its monthly cycle. You can see with a simple demonstration that any sphere lit from one side and viewed from different angles will take on these shapes. Also, it's important to remember that the Sun is about 400 times farther away than the Moon, so sometimes the lighted side doesn't look like it points directly to the Sun, but you have to think three-dimensionally to see that it does. Some flat earthers think the phases of the Moon are supposed to be caused by the Earth's shadow. That is wrong. The shadow we normally see on the Moon is just the Moon's own shadow, the side that is shaded because it is away from the Sun. This is very different from lunar eclipses, when the Earth's shadow is seen on the Moon. More on that later. Some flat earthers will claim the Moon gives off its own light, rather than reflecting the Sun's light. This is simply impossible. What mechanism could possibly explain how a big rock gives off light, which just happens to move across the surface in a pattern corresponding to the direction of the Sun? And when the Moon is less than full, it is easy to see shadows in its craters and on the side of its mountains, proving that the light is external. The Moon cannot be its own light source. It cannot work, it makes no sense, and has no plausible mechanism. The evidence all shows that the Moon is a big, reflecting, spherical rock. When we look at the Moon from anywhere on Earth, we see the same face of it, with the same distinctive craters and large dark areas called mare. This is because the Moon rotates at the same rate that it revolves around the Earth. It does this because the pull of the Earth's gravity caused a slight bulging of the Moon, and gradually that slowed the Moon down until its rotation rate, relative to the Earth, reached 0. This is called tidal locking, and it is not unique to our Moon. It occurs in most of the large moons in our solar system as well, and also the planet Mercury. The Moon is about 239,000 miles from Earth. In most diagrams of the Earth and Moon, you will see them close together like this, but this is not nearly the correct scale. When drawn to scale, we see that the moon is way out in the distance, about 30 times the width of the Earth away. This is why we are able to see the same face of it from everywhere on Earth. At that distance, our angle of view is essentially the same from all locations on Earth. How do we know it's that far away? Well, there are a number of ways to determine the distance to the moon. One way is by measuring the moon's angle above the horizon simultaneously from two distant points on Earth, and then using simple trigonometry to calculate the height. When this is done, the distance to the moon is calculated to around 239,000 miles, and this closely matches other modern methods of measuring the distance, including radar and lasers, and also ancient methods, such as using lunar eclipse geometry. But since the method uses the horizon, the calculation works out quite differently if you assume the Earth is flat, because you then assume the horizon is the same in both locations, while on the curved Earth you need to compensate for the curve of the Earth between the 2 points. So, assuming a flat Earth puts the moon much closer, and flat earthers calculate the moon is only about 3,000 miles away. So how can we tell who is right? Well, besides all the other evidence for the curved Earth, we know the moon cannot possibly be that close, due to the simple fact that everyone on Earth always sees the same face of the moon when it is visible in the sky. If it were only 3,000 miles away, that simply would not be possible. Let's look at an example on the flat Earth map to demonstrate this. When the moon is visible, you can see it from Maine in North America and southern Argentina in South America at the same time, since they are at the same longitude. They are each about 3,000 miles from the equator. So, if the moon is only 3,000 miles high, above the equator on the flat Earth, when viewed from the side, this forms a right triangle, with the viewing angles to the moon being 45 degrees in each location. Anyone notice the problem? This means that in each location, a person would be viewing the moon at an angle that is about 90 degrees different from the other location. They simply could not possibly both see the same features on the same side of the moon, but of course, in reality, they do. Also, if the moon is full for the northern observer, it would be only about half full for the southern observer. But we know that the moon's phases are seen almost exactly the same everywhere on the Earth at the same time. The only way you could see the same side of the moon and the same phase everywhere on Earth is if it is far out in the distance, so that all viewing angles are essentially the same. You can verify this yourself. Find someone in a different part of the world and ask them what phase the moon is in. They will always see the same phase that you see, or very close to it, on the same day. This is not possible with a close moon circling above a flat Earth. Another way the moon reveals the shape of the Earth is with lunar eclipses. This is when the Earth's round shadow can be seen crossing the face of the moon. They can happen as often as once every 6 months, and are visible everywhere on the night side of the Earth when they occur. They don't happen every month for one simple reason. The moon's orbit around the Earth is tilted about 5 degrees from the Earth's orbit around the sun. When shown to proper scale, with the moon about 30 Earth diameters away, you can see how the orbital tilt of 5 degrees can cause the moon to pass below or above Earth's shadow. This animation shows the variation of the moon's position in relation to the Earth's shadow when it reaches full moon each month. Most months it passes above or below the shadow. Only when the angle of the moon's orbit is aligned with Earth's orbit at full moon does a lunar eclipse occur. This is a great example of how flat earthers' objections to the globe are based on a misunderstanding of the facts. They often claim an eclipse should happen every month, but this is because they do not understand the scale of the Earth-Moon system and the 5-degree tilt of the moon's orbit. They are not arguing against the actual facts. They are arguing against their own ideas of how they think it is supposed to work. This is called a straw man fallacy. When you get the facts right and understand all the relationships, scales, and concepts involved, you will see it really all does work. Your biggest problem is your misunderstanding of the model. My goal is to clear up as many of these misunderstandings as I can. When the orbit of the moon is aligned with the Earth at full moon, a full or partial lunar eclipse occurs, and we see the large circular shadow of the Earth pass over the moon. The Earth is about 4 times the size of the moon, but its shadow on the moon is a little less than that because the shadow is slightly cone-shaped. Since we know the distance to the moon, we can calculate the size of the Earth from its shadow using simple geometry, which comes out to 7,917 miles in diameter, and this matches all other measurements. As the moon is covered by the Earth's shadow, it begins to appear reddish, often called a blood moon. This occurs because of the reddish light of the Earth's atmosphere glowing on the darkened moon. It's red for the same reason sunsets are often red. Red light can pass through the atmosphere and not get scattered much, while light at the blue end of the spectrum is more easily scattered. So at sunrise and sunset, when the sunlight travels a long path through the atmosphere, the blue light has been mostly removed, leaving mostly red and yellow light remaining. The eclipsed moon is lit by a sunset that circles the globe from its perspective. This red color is further confirmation that the lunar eclipse is caused by the shadow of the Earth. I've seen some flat earthers claim that it is impossible to cast a red shadow. No, that's just wrong. The Earth doesn't really cast a red shadow on the moon per se. It blocks the most direct white light of the sun and shines a dim red light on the darkened surface. What is the flat Earth model's explanation for lunar eclipses? They really don't have one. Some of them claim it is probably due to a semi-transparent disk passing in front of the sun and shading the moon, sometimes called the anti-moon or shadow object. But they have no observations of it outside of eclipses, and no explanation for what it is, why it never casts shade on the Earth or blocks the stars, what holds it up, or what makes it move. It's just a special pleading fallacy with zero evidence, an attempt to save their belief from contradictory evidence. Another serious problem with the flat Earth model is that flat earthers never explain what force keeps the moon circling above the flat Earth. There is no known force that can do this. Is it magic? Is it supposed to be attached to the dome or firmament? They never really say. But of course, that could not work because it moves at a different speed and in a different path than the stars and the sun and the planets. And also, it goes in front of the sun during solar eclipses. And also, the moon's orbit, like nearly all other orbits, is not perfectly circular, but slightly elliptical. So its distance from Earth varies, and we can see this because its apparent visual size varies by as much as 12%. What force in the flat Earth model can cause that? Does it go up and down? Does it shrink and grow? In reality, we know exactly what keeps the moon moving across our sky. It's called gravity. The moon orbits the Earth due to the pull of Earth's gravity. Many of you have said that gravity has never been proven, or even that it doesn't exist. It's hard for me to describe exactly how ridiculous that is. I am still astounded when I hear a flat earther say this. You are denying something that we all easily observe every day. There is no force or phenomenon that is more scientifically proven than gravity. You don't have to understand the physics of why it works to see that it does work, and works the same everywhere in the universe. The same force that is holding you down right now, and has for your entire life, is the same force that causes all dropped or thrown objects to be pulled back down to the Earth in a precisely predictable way, and is the same force that holds the moon circling around the Earth. This is how all orbits work. Smaller objects near bigger objects are pulled in by gravity. Some will crash right into the bigger object, and some will be going too fast and fly on by. But if they are going the right speed, they will be pulled into an elliptical path around the object. But that pull is counteracted by the centrifugal force outward caused by the revolutions around the object. And because there is virtually no friction in space, objects can remain in orbit indefinitely. A very easy way to observe orbits, other than our own moon, is to look at the moons of Jupiter through a telescope. I've done this many times, and it's a very amazing sight. If you don't have a telescope, find someone who does. There are astronomy clubs all over the world that will gladly let you have a look. The 4 biggest moons of Jupiter orbit the planet in a short amount of time, and you can actually see their movements within a single night. Their movements are exactly predicted by the force of gravity, the same force that keeps our moon in orbit around the Earth. You really cannot honestly say gravity has never been proven. This sight alone proves it, and you can see it for yourself. When I started this series, I really didn't think I would have to explain that gravity exists and how we know it exists. It is something we all experience constantly, and we can easily test it ourselves. Unless you are completely delusional, you accept that things are pulled down. So your only problem, really, is the direction of the pull. On a giant sphere with trillions of tons of mass, the direction of pull is toward the center of mass of the sphere. You take it for granted that things are always pulled down, but down is relative. Everywhere on Earth, down is toward the center. And no, gravity is not just density and buoyancy. Density and buoyancy are factors in how gravity works, but alone they don't explain the consistent direction of the force. It's gravity that causes the force to have a specific direction, down toward the center of the Earth. Since we are talking about gravity, I want to address another issue that keeps coming up. Flat Earthers keep asking how gravity can hold everything to the Earth, including the oceans, if it is spinning at 1,000 miles per hour. Well, there is a huge misconception here. Yes, it is true that the surface of the Earth does move at about 1,000 miles per hour at the equator, but that is irrelevant and misleading. The Earth only spins once per day. That is very slow. When you say 1,000 miles per hour, you make it seem like the Earth spins very fast, like a top. And some flat earthers use words like rapidly, fast, and whizzing around when describing the spin. It doesn't whiz around. It barely moves. The speed of the stars moving overhead each night is the speed of the rotation, and you won't notice them move without watching for a long time. The Earth spins once per day. That is twice as slow as the hour hand on your watch. It's only 15 degrees per hour. The only reason it is 1,000 miles per hour at the surface is because the Earth is so big. And a slow spin doesn't generate a lot of centrifugal force. Think of it this way. Hold a ball on a string and spin around fast. The ball is pulled outward by centrifugal force. Now, spin so slowly that it takes a full day to make one rotation. The ball will hang right down. Because the spin is so slow, there is almost no centrifugal force. That is the same for the Earth. The centrifugal force is so weak, it is only about 0.3% as strong as the pull of gravity. That is why we don't feel it, and why nothing, including the oceans, gets flung off into space. We can actually measure the tiny effect of centrifugal force, because objects weigh slightly less at the equator than they do at the poles. Every time you hear someone imply the Earth spins really fast at 1,000 miles per hour, think once per day. If I can get you to understand this simple concept, you will start to see why it's perfectly reasonable that we live on a spinning ball. All your objections are based on misconceptions, misunderstandings of physics, geometry, and scale, and flat-out denial of easily observable facts. Once again, I have shown you observations we can all make that show us the Earth must be a sphere. There is no other reasonable way to explain these facts. The flat Earth model cannot explain why we all see the same face of the moon, and also the same phase of the moon, from every spot on Earth on the same day. And it cannot explain why we have lunar eclipses that show us the Earth's round shadow in precisely the predicted size, position, and time. Flat Earthers struggle to explain these things with outlandish, implausible, and unsupported claims. Some of these would require inventing whole new laws of physics to explain them. But there is no need for that, because the heliocentric globe model explains all of it, with easily observed and tested physical forces. Thanks for watching. This is part 4 of the series, Proving the Earth is Not Flat. Since the beginning of this series, I said there would be experiments. So finally, in this segment, I am going to show you 2 simple experiments you can do to prove to yourself that the Earth is a sphere. I picked experiments that are very easy and don't require any expensive equipment. I will show you how to do the experiments, and will show you my results, and explain what they mean for the heliocentric globe-Earth model and for the failed flat Earth conjecture. The first experiment dates back over 2,200 years. Aristarchus of Samos, who lived about 310 to 230 BCE, was the first known heliocentrist, centuries ahead of his time, and was a brilliant mathematician and astronomer. He realized that using simple geometry, one could easily determine the relative distances of the sun and the moon. Since the moon's phases are caused by the light of the sun and our viewing angle, he realized that at first quarter and third quarter phase, when the moon precisely appears half lit and half dark from our vantage point, that the Earth, moon, and sun form a right triangle. So if you can measure the angle between the sun and the moon, simple trigonometry will tell us the relative distances of the two objects. Now bear with me on this. There is some math involved, but you will see it's very simple math. First, in Mythbuster style, let's try this on a tiny scale to show how it works. These two objects and the viewer form a right triangle. This angle is 90 degrees, and with a simple protractor, we can measure this angle, which is the viewer's angle between the two objects. In our example, we get 67 degrees. Once we know that angle, even without knowing the distances, we can calculate the ratio of the distances of the two objects. In other words, how many times farther away is object B than object A? I will explain why this ratio is important later. To get the ratio, we simply calculate the secant of the angle, which is the trigonometry calculation for the ratio of the length of the hypotenuse over the length of the adjacent side. I put a link in the description for the explanation of this, in case your trigonometry is rusty. In our example, this comes out to 2.56. So this means that object B is 2.56 times farther away than object A. And since we can measure the distances here, we can verify that the right triangle method is valid by seeing if we get the same result by measuring. We see that the distance to A is 7 inches, and the distance to B is 18 inches. And so, when we divide 18 by 7, we get almost exactly the same ratio, 2.57. So now we know the method works. Try it yourself with any distances. So now let's try it with the sun and moon. To do the experiment myself, I spent about $20 on this angle tool with a digital readout. You can use a simple protractor, but you will need to add some form of pointing device for alignment. Check timeanddate.com or any other moon phase chart and go out on the date of the first quarter or the third quarter moon. It is easiest when the sun and moon are low in the sky, and of course you will need clear skies. Here you can see how I lined up one side of the angle finder with the moon. And to save my eyes from sun damage, I affixed a piece of index card on the other side. This way I could move the arm until the sun's shadow lined up straight down the arm, and I could tell it was aligned with the sun. Never look directly at the sun. I did the experiment 3 times on different days and in different locations. My results were very close together, 88.3, 87.5, and 86.1. So let's use the average of 87.3. At 87.3, the distance ratio calculates to 21.2, meaning the sun is 21.2 times farther away than the moon. Now let's see how this observation fits with the flat Earth model. Now I understand that flat earthers have yet to come up with a map they all agree on. But it would have to look something like this azimuthal equidistant projection map, even though there are, of course, many problems with it. Australia is not wider than the US, for example. But we have to use something, and this is the map most of them seem to agree on. So now I'm going to try to create the best case scenario for the flat Earth model. I will use the maximum possible sun-moon distance and the minimum possible viewer's distance to the moon. So if the moon and sun are both circling above the flat Earth, then we can roughly determine the maximum sun-moon distance allowable in the model. Let's put the sun at its maximum distance from the North Pole, which would be the December solstice, right above the Tropic of Capricorn. And let's put the moon on the opposite side, at its maximum declination, which is about the same latitude. This would make the distance between the two about 15,500 miles. And now, let's put a viewer directly below the moon overhead. Flat earthers seem to agree that both the sun and moon are about 3,000 miles high, so that is what I will use. If you say they are higher, then you are going to have even greater problem explaining why they can set. This is already a huge problem, but I'm going with your model. So now we draw a triangle and measure the sun-moon angle directly with a protractor, and we get just under 80 degrees. And taking the secant of that, we see that the sun can be at most 5.76 times the distance of the sun. But remember, we calculated it was 21.2 times more distant with our actual observation of the sun and moon. That's a huge difference. And to see why this is so devastating for the flat Earth model, let's see what an angle of 87.3 and a ratio of 21.2, as I observed, would look like on the flat Earth map. This would put the sun way off the map, way below the South Pole. There is no way the flat Earth could work if the sun was way off to the side of all the land masses. And, as it turns out, my number is a little bit low. Aristarchus, using rudimentary tools, measured the angle between the sun and moon at 87 degrees, which is right near the average of my 3 measurements. While his method was correct, his measurement capability was not very accurate. Today, with much more accurate measuring capability, astronomers measure the angle to be 89.85 degrees. This puts the sun about 382 times farther than the moon, and this agrees with several other methods we have today for determining the sun's distance. The number I got is conservative. The more accurate you measure, the worse it gets for the flat Earth model. Remember, I used the best case scenario for the flat Earth model. If you make the observer farther away, or make the sun closer, the viewing angle gets even smaller, but you need it to get bigger. Do the experiment. See what angle you get. You would have to get an angle close to 80 degrees or lower for it to even have a chance of working for the flat Earth model. But you will see it is close to 87 to 90 degrees. If you do this experiment and are still a flat earther, then it's time to admit you are not looking at the question scientifically. The second experiment is called the equinox sun. This is a simple experiment that anyone can do, anywhere in the world. Every 6 months, at the spring or fall equinox, the sun rises and sets exactly due east and west, no matter where you are on the earth. This is due to the spherical shape of the Earth and the Earth's tilt. At the equinoxes, the Earth's axial tilt is sideways with respect to the Sun. So on every place on the Earth, as we rotate west to east along our latitude, we all see the Sun appear due east and set due west. The rest of the year, the Sun will rise and set a bit to the north or south, due to the Earth's tilt being toward or away from the Sun. A good way to test this is to find a street that runs due east-west and watch the Sun rise or set down the street. I did this test on the fall equinox, September 22, 2016, on a short east-west street in Orange County, California. I filmed the Sun setting directly to the west down the street. There are some coastal hills here, so it is setting behind them rather than the true horizon, but you can tell that it is angling directly toward due west at the horizontal plane. Allow me to demonstrate why this works on a globe model. I set the globe up with a light representing the Sun and the tilt leaning sideways to that light. This is the Earth's position at spring or fall equinox. So we see, as we rotate the globe, viewers along the same longitude cross into sunlight at the same time. This is equivalent to their sunrise. But notice which direction they all must face to watch the sunrise. It is exactly east, because the Earth rotates along the lines of latitude, and this is perpendicular to the Sun at equinox. Now let's try to picture this on a flat Earth model. If the Sun is circling above the flat Earth, then the direction you see it rise and set at any time of the year, including at equinox, will vary greatly depending on your location. As you can see in this animation, the further south you are, the further north the Sun would appear at sunrise and sunset, and vice versa. This is not what we see in reality. There is no way to make the equinox Sun work on the flat Earth model. A YouTuber named Dazza the Cameraman recently issued what he called the Equinox Challenge, asking people to do this experiment and post their results. Many have done so. Go to YouTube and look at these, and also try it yourself, and try to find a valid explanation for the flat Earth model. It simply cannot work. For many months now, many of you flat earthers have been telling me I need to do my own research, while you largely ignore all the evidence I have provided in this series. So now it's time for you to put your belief to the test. Do these two experiments carefully and honestly, and then try to explain your results with the flat Earth model. You will see why the flat Earth model simply does not fit the reality in which we live. Only a spinning, sun-orbiting sphere explains all these observations. Thanks for watching.